Alright, so we're going to talk about some measures of variability. Measures of variability are telling us about how spread apart our data is overall. So one of the simplest versions is called the range. So to calculate the range, we're going to take, so our range is going to be equal to our maximum observation minus our minimum observation. So in our case, we're going to have a range equal to our maximum observation of 17 minus our minimum observation, just 4. So we'll have a range of 13. And I should say this is the sample range. So the sample range is for the sample. You can do this also for a population, but we're talking in samples through all of this. So we have that. Now, other things that we have that can help us talk about how spread out our data is this idea of a sample variance. So in the sample variance, this is actually s squared, and it's going to equal the sum from I equals 1 to n of x sub I minus our sample mean x bar squared, and we're going to divide it by n minus 1. Alright, so going through our example and calculating this, the first thing that we need to know is what our mean is. So to find our mean, our sample mean, we have x bar equals 17 plus 6 plus 5 plus 4 divided by 4. So when we do this, we have 17 plus 6 is 23, plus 5 is 28, plus 4 is 32, divided by 4 is going to give us a mean of 8. So to find our sample variance, we're going to do s squared is going to equal the sum from I equals 1 to 4 of x sub I minus 8 squared, all divided by 4, because I have 4 elements in my sample, minus 1, so 3. So when I go through and I do this, I'm going to get my first observation. I have 5, so I'm going to do 5 minus 8 squared divided by 3 plus 17 minus 8 squared divided by 3 plus 6 minus 8 squared divided by 3 plus 4 minus 8 squared divided by 3. So now if I work this out, 5 minus 8 is negative 3 squared divided by 3. 17 minus 8 is 9 squared divided by 3. 6 minus 8 is negative 2 squared divided by 3. 4 minus 8 is minus 4 squared divided by 3. And I keep working this out. Negative 3 squared is 9 divided by 3. 9 squared is 81 divided by 3. If negative 2 squared is 4 divided by 3. Negative 4 squared is 16 divided by 3. So if I add all of this up, I get 9 plus 81 is 90, plus 4 is 94, plus 16 is 110 divided by 3. And when I do that subtraction, I get, or that division, sorry, I get 3, 6, and 2/3. So this value n has come up, and when we've talked about n, it's been our sample size. So in our sample variance equation, you'll notice that there's an n minus 1. This n minus 1 is actually called the degrees of freedom. And what the degrees of freedom tells us is how many values could be any random numbers that we choose in our observations. So it's not that we get to make up data, but it's that a sample that's this size with this sample variance, I can have n minus 1 values that are totally random, but that last one, that nth value, is going to be determined. So there's basically n minus 1 of these values that are free to be whatever, and they still could, the coming up with this variance is still a possibility. And you can kind of see this playing out when you see, when we took our differences, we had -3, 9, a -2, and a -4. If you add all of those up, they equal 0. And that's always going to be the case because of the nature of the mean and it being the average, truly the average of all of these observations. So that's our degrees of freedom idea. All right. So one of the things that we hear even more than the sample variance is we hear about the sample standard deviation. And the sample standard deviation is actually written as S, and S is just the square root of S squared. And remember, S squared was our sample variance. So in our case, we'll have S equals the square root of 36 and 2/3. So if we do this, we'll get just over 6, about 0.5-ish. All right, so just over 6. And the standard deviation is telling us again about how spread out our data really truly is. There are multiple ways that we can display data. So in the book, it talks about histograms, it talks about dot plots, it talks about stem and leaf plots. All of these things are really good things for you to brush up on if you don't remember them. We're going to talk specifically about box plots because they're probably the one that we're going to use the most and probably the ones that have left your minds the most. So to make a box plot, the first thing you need to do is kind of look at the range of your data. So you look at it, and my data here is in increasing order for me, which is going to help me out. So I need to go from 2 to 20. And what you do is you go through and you make a very accurate and detailed number line. So I'm going to start at 0. I'm going to get up to 20. And ideally, you're using a ruler and you're getting to mark these off actually measured out and in in a super careful way. So once you've got your number line, we need to find the median. So to find the median, we're going to take our x tilde, and it's going to be equal to 1/2 times the quantity x sub n over 2 plus x sub n over 2 plus 1. So we're taking our middle two terms, we're adding them together and dividing by 2. So we're taking the average of the middle two terms here. So I have 1/2 times x5 plus x5 plus 1 is x6. And since I have these in increasing order already, I have x1, 2, 3, 4, 5. So I'm going to take a 7, and I'm adding to that the next one, the sixth one, which is 9, and I'm going to take half of that. So 1/2 times 16 is 8. So the median of my data set is 8. So to make my box plot, I'm going to take and I'm going to mark at 8 on my number line. So this is about 5, 6, 7, 8, 9. So at 8, I make a vertical line like that. And different people do this different ways. I'm a big fan of making sure that it's very clear that that line is in fact at 8, all right? And you can even do things like label it as your median there, all right? Once you have your median, then you basically go through and you say, all right, there's my median value in my data. I've cut my data into 2 parts now. And what you end up needing then is what's called your first quartile. So Q sub 1 is the median of the first half of your data. So I look at my data and I say, all right, I have an odd number of entries there now. I have 5. So my median is going to be my x sub 3, right? And it's going to be my x sub n plus 1 over 2. So 5 plus 1 is 6, divided by 2 is 3. So x sub 3, and x sub 3 is my third entry here, which is 5. So once you have your first quartile value, you put a vertical line there. And again, it's a great idea to label it as your first quartile. And your median is the same as your second quartile. And then you can be looking at the second half of the data to find what's called your third quartile. So the third quartile is the median of the second half of the data. So again, there's 5 entries there. And so we want the third one. And so we're going to look at x sub 3 in the second half, which is 17. And so you go through and we got kind of 16, 17, 18, 19 on our markings. And at 17, we make a mark, and that is the third quartile. So once we have those things marked, then we go and we draw a line across the top of our bars and a line across the bottom of our bars, and we have this box here. So a lot of times these are just called box plots. Your book calls it a box and whisker plot. You might have learned it as that also. And the whisker part comes in that you take the minimum value of your data. So here I have 2 as my minimum, and you mark that minimum value. All right, so my minimum value is 2. There it is. And this is the min. Some people write min. You don't have to. And you connect that dot to your box. And then you do the same thing up on the max end. So you take your largest data value, you mark it. Some people, again, label it, others don't. It's up to you. I think it's always a good practice to label stuff. And then we connect that. So what we've done is we've made a really well labeled box plot, box and whisker plot here. And what these quartiles mean, quart sounds like quarter, right? A quarter of the data falls, if I look at this, between the minimum and quartile 1. This is 25% of the data falls in that window that's marked by that line. And then another 25% falls within this first half of my box. And another 25% of my data falls in the second half of my box. And another 25% falls in the part between the quartile 3 and the max. So we have 4 quarters that these quartiles break our data into. So it's a super useful plot.